Differential equations, section 4.2, day 1. Let's start off with a little bit of review. We saw this really in our first lesson's notes too. Let's say we have an nth order homogeneous differential equation. We'd expect for there to be n separate linear independent solutions. And that means, of course, if we had a fourth derivative being the highest power, we'd expect for there to be 4 linearly independent solutions. The general solution, once you show that they are linearly independent with the Wronskian determinant, you could see that really it would be a combination of C1 times Y1 plus a second constant times Y2, continuing to add those all the way up to your nth solution. So again, this is for a homogeneous differential equation where the right side is 0. Well, of course, who says that the right side is 0? The right side could be a constant like 5. It could be something like e to the 4x. It could be a function like that. Let's just say you have a non-homogeneous differential equation. You would expect for there to be n linearly independent solutions from a general solution, but we'd also expect to have a particular solution. That's coming down the road. We're still going to solve a differential equation that's equal to something other than 0, solve it equal to 0 to get this general solution. But then we would look at the particular. We'd say, what if that right side really was non-zero? Could we come up with solutions there? And then we could say that the most general solution would be y equals y sub c plus y sub p. Well, what we're about to do today, just having this little bit of an introduction, super short video just as an introduction. The particular solution should be linearly independent from other solutions. We're going back, though, to today. You know, we've been talking so much about non-homogeneous just lately. Before we get there, we're going to spend one more day with the right side equal to 0. So we just had a little bit of a review right there, but we're going to take a look at one more day where our right side is 0. If I know that we have one solution, perhaps we see it, perhaps it's just given to us. Very often they're going to give it to you. How could you find a second solution if it's a second order? Second order, we'd expect 2 solutions. Here's a great method. We're going to let y equal u of x times y sub 1. Where y sub 1 is one of the solutions. So y sub 1 is known. They tell you it works. Well, very importantly, we're going to assume that u of x is not a constant. That's what we're seeing right here. And that would mean that y divided by y sub 1, which is u, it's not just going to be a constant. If it was, then really we wouldn't be linearly independent. But once we work with this general unknown u of x, we're going to do the following next 3 steps. We're going to substitute that expression in for y, y prime, and y double prime. We'll have to take a first and a second derivative. Then we'll use reduction of order. We're going to let w equal u prime. And we can let w prime equal u double prime to be set up for that second order just as well. So we'll have a u double prime somewhere as we do that. W prime would be there, so we're going to substitute these 2 things in. Then we'll solve our linear equation for u and then substitute it to find y.